Hello, today I'm going to talk about array formulas in Microsoft Excel. First off, an array is going to be a collection of items. Their normal formulas in Excel take variables as inputs. However, array formulas take arrays of variables as inputs. For array formulas, there are two main types of array formulas: a single cell formula and a multi-cell formula. A single cell formula is essentially a for loop inside of a cell. That means that given the array, the formula acts upon each element of that array and returns a single result in that cell. Multi-cell formulas are a little bit less common, but they do still provide security and flexibility. I will go over some of these examples in the future. When entering an array formula into Excel, you have to use Control plus Shift plus Enter at the same time when exiting that cell. Because of this, array formulas are sometimes called CSE formulas. They are noted by curly brackets, as you can see here on the left and right side of the formula when looking at the formula bar. If you don't see the curly brackets, Excel will either provide an error or treat it as a normal function, which can be problematic, so you have to be careful. Why should we use array formulas? Well, there are three main reasons. First off, consistency, meaning that the same formula is entered into each cell of the multi-cell array formula. Also for safety, if you do have a multi-cell array formula, you cannot change part of the array formula without changing the entire array formula. The third one is a smaller file size. You only have to enter one formula instead of multiple formulas when acting on a large table. If you have a small file, this might not be that big of a concern, but if you have hundreds or thousands of data rows, then this can add up and you can save kilobytes or even megabytes with a very large file. Let's look at some examples in Excel. First off, I have two columns, A and B. I want to add each one of these together. I can use a simple array formula that you can see up here in the formula bar. Is going to be the range of A2 to A11 plus B2 to B11. Ranges are denoted by this colon in between two different cells in Excel. You can see this is going to be an array formula with the curly brackets on the left and the right side. For consistency, you can see that as I go through this array formula, it's going to be the same range and same formula as I go up and down the entire array here in column C. Safety. If I try to delete one of these cells, I get an error message saying that I cannot change part of array. Now looking at the file size, if I have this array formula, it's going to be the same formula up and down the entire array. If I want to have the same formula using a normal Excel formula, I have to have A2 plus B2, A3 plus B3, A4 plus B4, meaning for this data set, I would have to have 10 unique formulas instead of simply one formula. Now looking at the file size without an array formula, it would be 9.092 kilobytes. Now with the array formula, 9.071 kilobytes. Now this may not seem like a lot, but you do end up saving about 20 bytes when using the array formula to create a smaller file size. Another thing to note is in this array formula, I have a range that's going to be 10 cells long for my A column, 10 cells long for my B column, and I have 10 cells up and down for this multi-cell array formula. The main concern here is that if you have the variable arrays, column A and column B, these two have to equal each other in size, meaning it has to be one column by 10 rows array for A and one column by 10 rows for B in order for proper array formulas to work. Let's look at some future examples. Excel has some of these array formulas built into itself as default normal formulas, but there aren't very many of them. A good way to start off thinking about what an array formula is by looking at one of these built-in Excel formulas, the SUMIF. The SUMIF formula will take a range and a condition and will sum all the values in that range that meet a specific condition. So if we're looking at this formula here, we're looking at cells A2 to A22, so 21 cell range, and for anything that's going to be greater than 0, Excel is going to pass that variable of the array back to the sum function and add it together. So for this example, we're adding 1 plus 2 plus 3 all the way up to 10 to get 55. Now looking at the array formula, this provides the exact same formula as the built-in SUMIF. You can see that we have this as an array formula with the curly brackets on the left and the right hand side. And if we look at the arguments inside of each of these formulas, the if statement here tells us that we're going to be looking at the array of cells from A2 to A22, and if each one of those cells in that array is greater than 0, we're going to pass that exact same cell back to the sum function. If the cell in that array does not, or is not greater than 0, then we're going to ignore it. We're going to pass a false statement back to the sum function, and that false statement is going to simply ignore that current cell. So by this simple sum and if statements together, we get the same as the built-in SUMIF array formula. Now, one of the useful things about using array formulas on a data set is you can combine multiple conditions in order to get a single output. To combine these conditions, we can use a Boolean AND or a Boolean OR. This is simply done by either using a multiplication sign for a Boolean AND or an addition sign for a Boolean OR. Now let's look at each one of these. First off, before we continue, should note that Excel treats 0 as a false statement and any positive number that is not 0 as a true statement. So if we look at this statement here, we're using the traditional sum and if statements together. Looking at the first if statement, saying if the array from C2 to C13 equals Asia, then return a true statement or the 1. And if the array from B2 to B13 in the product category equals CFF, return true or an Excel 1. And now we're going to take each one of these and multiply them together. So if the location equals Asia and the product equals CFF, you're going to have 1 multiplied by 1, and that's going to return an Excel true. So you'll get this first statement here for Excel, or for the if statement, 1. And if these do not equal 1, then you're going to get 0. So if the location does not equal Asia, if it equals either US or Europe, this part of the if statement is going to be 0. 0 multiplied by anything is going to be 0. That's going to be an Excel false, which returns this 0 over here. Or if the product does not equal CFF, it's going to return 0. 0 times anything is going to be 0, giving you the Excel 0 for this first part of the statement, and it returns 0 over here. So by using that multiplication sign, it means that every single thing in this if condition has to be true in order to return 1. Otherwise, you're going to return 0. Now, with this here, we're going to multiply each one of the units that we sold, pass that value back to the sum statement, and sum everything up. So now, if we use Control-Shift-Enter, we can exit out of that array formula and look at the value. So it's going to be 936, which is going to be this red value over here, 596 plus 340. Now if we want to look at an OR statement, we can say that we want to look at all products that were sold in the US here. So the location of the array C2 to C13 has to equal US. Or, with this plus sign, we're going to look at the array C2 to C13 equals Europe. If either one of these is true, you're going to have 1 plus either 0 or 1, which is going to return a number greater than 0. So that will be the same or the equivalent of an Excel true statement, and you're going to get 1 over here. However, if it doesn't equal the US, you're going to return 0. Or if it doesn't equal Europe, you're going to return 0 for here also. 0 plus 0 is going to be an Excel false, which returns this 0 over here, and then you have this if statement, or this if condition, multiplied by the units again, and you're going to return with the value. So if we look at that, it's going to be everything in this green, so US or Europe for the CFFs for Representative Joe, Silver Series for Joe, CFFs for Mike, and Silver Series for Mike, with all the values down here in the light green. Now if we want to look at something that might be a little bit more practical and large tables that might have some errors in them, we can look at the is_err function and combine that with the sum and if statements. So normally if we want to look at the sum or the average or the count of units over here, that works well if every single thing in our array is going to be numeric. However, if we have an error in that array, such as a divide by 0 or a pound number or a pound value, then we can't simply do a sum on the entire array over here, or else we're going to get an error. Same thing with an average of looking at this. If we simply take the average of all the values and there's an error in there, we're going to get an error. If I look at the summation of it, I would have to manually come over here, sum the values that are true values, and manually exclude the error value inside of each of the sum statements in order to get it properly. However, if we're dealing with hundreds or thousands of rows, I might not know where this error actually is. Well, by using an array formula, I can use the is_err statement that's built into Excel as my if condition, meaning if the array from D2 to D13 is an error, that's going to return true. For the if true condition, I'm going to pass a false statement to the sum statement, meaning this false condition right here tells the sum statement to completely ignore that cell that we're dealing with. However, if it's not an error, then I'm going to pass that cell value back to the sum statement. So from the array D2 to D13, it's going to pass all the values that are not an error back to the sum statement, but when it finally gets to D9 down here, it's going to pass a false because that is an error. So you can see that with the array formula, we get the same as manually looking at each one of the numbers in here. Same thing with the average formula. I can use the is_err statement, and as soon as we get to that cell D9, it's going to pass a false statement back to the average, and if not, it's going to pass the actual value back. When it passes that false statement, it completely ignores that cell, so you still have a valid average with the sum in the numerator and the proper count in the denominator. Now if we look at a multi-cell array formula, the most common one is going to be a transpose. A transpose takes a table of rows and columns and flips it so that you have a table of columns and rows. So if we look at this same sales table that we had before, and we want to have the column titles over here, the rep, product, location, units, and revenue, as being vertical rows, and then having all the values being the columns, we can simply look at that 5 by 13 table and then first off highlight a 13 column by 5 row table. Once I have that highlighted, I simply enter transpose into the first cell of that highlighted range, highlight the table I want to switch rows for columns for, close parentheses, and hit Control-Shift-Enter. Now I have everything switched, so the columns are rows and the rows are columns. As I mentioned before, if you want to delete part of this array, you cannot do that. So what might be useful once you have done this transpose is if you highlight all the cells, you can copy and paste values. So now you can actually come in here, we've removed the transpose array formula, and we can come in here and we can change the values if we want to. Hopefully this helped you out with a basic understanding of arrays.